BSM Academy, a School of Arts and Science. Particle Physics Part 1, Strong Nuclear Forces. Strong force binds the nucleus. The four fundamental forces of nature: electromagnetism, weak interaction forces, strong interaction forces, gravitation interaction forces. These are the four fundamental forces in nature. The nuclear force or the nucleon interaction or residual strong force is a force that acts between the protons and neutrons of atoms. The neutrons and protons, both nucleons, are affected by the nuclear force almost identically. The nuclear force binds nucleons into atomic nuclei. My dear friends, nucleon means maybe a proton or it may be a neutron. As we discussed about strong force binds the nucleus, electromagnetic force binds atoms, weak force in radioactive decay, gravitation force binds the solar system. These are the four important forces in the nature. In particle physics, the strong interaction is the mechanism responsible for the strong nuclear force, also called the strong force or nuclear strong force, and is one of the four known fundamental interactions, with the other being electromagnetism, weak interaction, and gravitation. The strong nuclear force is one of the four fundamental forces in nature. The other three are gravity, electromagnetism, and the weak force. As its name implies, the strong force is the strongest force of the four. Strong force, a fundamental interaction of the nature that acts between the subatomic particles of matter. What are the subatomic particles of matter, my dear friends? They are electrons, protons, neutrons, and furthermore we will discuss many more fundamental particles are there. The strong force binds quarks together in clusters to make more familiar subatomic particles such as protons and neutrons. The force that arises from the strong interaction of quarks, the short-range attractive force between baryons that holds together the nucleus of the atom. These are the important things what we have discussed already. The fundamental interaction forces that govern how objects or particles interact and how certain particles decay. All the known forces of nature can be traced to these fundamental interactions. The types of particles that experience the force, the relative strength of the force, the range over which the force is effective, the nature of particles that mediate the force. Again, the fundamental particles are important here in the discussion. Protons repels. As we know that law of charges, like charges repels and unlike charges attracts. Protons repel, electrons repel, opposite charges attracts, leads to the Coulomb's law. Like charges repel, unlike charges attracts, protons repel each other, and the same is true for all electrons, but the electromagnetic force attracts electron to protons. Electron capture in hydrogen, in case of hydrogen and oxygen, my dear friends, into the orbit around positively charged atomic nuclei. The larger the nuclei, the more electrons are pulled in. Atoms and molecules. The electromagnetic force holds atoms and molecules together. Electrons occupy energy levels around atomic nuclei, balancing out of positive and negative charges. These are the four fundamental forces in nature. Coming to the modern quantum physics and the modern physics, before the 20th century, the term matter included ordinary matter composed of atoms, excluded other energy phenomena such as light or sound. This concept of matter may be generalized from atoms to include any objects having mass even when at rest, but this is ill-defined because an object's mass can arise from its possibly massless constituents, motion and interaction energies. Matter, atom of the matter, electron of the atom, proton or a neutron of the nucleus, and the quarks of proton or neutron. You see, particle in particle, particle in particle, finally it leads to the matter. That means matter is having fundamental particles called atoms. Further, atoms are having subatomic particles called electrons, and the nucleus protons and neutrons, and sub-fundamental particles proton, neutron, and quarks. See, my dear friends, atoms, molecules, matter, earth, starting from earth is composed of matter. This matter is composed of atoms and molecules. This is composed of proton, neutron, and electron, and the quark, the proton. Further, it is subatomic particles. So strong force, a fundamental interaction here, you can see the proton. And the strong force binds quarks together in clusters to make more familiar subatomic particles, such as protons or neutrons. The force that arises from the strong interaction of quarks, the short-range attractive force between the baryons that holds together the nucleus of the atom. The strong nuclear force is one of the four fundamental forces in nature. The other three are gravity, electromagnetism, and the weak force, my dear friends. So coming to the baryon is a composite subatomic particle made up of three quarks as distinct from mesons, which are composed of one quark and one antiquark. The baryon is made up of gluon and quark. These are the fundamental subatomic particles. Baryons may be a proton or a neutron, and a meson may be a pion and a kaon. So these are the subatomic particles, my dear friends. Baryon is composite subatomic particle made up of three quarks, gluon and quark. Thank you for watching. Like, share, and subscribe.